So let's look at what the messaging patterns, which messaging patterns we're talking about here. So typical capital markets applications deal with a lot of real-time data. There is data from stock markets, from order management systems, from news applications, news feeds, and so on. And all of this information needs to be, given to the traders and portfolio managers and the users who basically need all this, use all this data in real time. So the typical push-based messaging pattern in any client-server kind of a scenario would be something like a publish-subscribe, for example. A publish-subscribe could be that your application subscribes to certain stock symbols, and the server publishes the current market prices for those symbols. Or it could be a broadcast where the server is broadcasting the current news feeds, and whoever wants to listen basically looks at it and so on. Or it could be a multicast where the server needs to push out an information, but it is meant for a specific set of audience. So maybe there is a particular order which is relevant to a particular desk. All the traders on a particular desk need to look at that order, and therefore it is a multicast scenario where information is pushed by the server to a certain set of audience. So keep these scenarios in mind while we do the rest of the discussions, and these will help us guide through some of the decisions that we make and some of the architecture issues that we look at. Looking at how we used to do it traditionally. Now, in thick client applications, it was it is typically easy where you have a queuing infrastructure or message-oriented middleware, and your thick clients can connect over TCP to that kind of infrastructure. But what if your applications were web-based? In a web-based scenario, these push messaging patterns were significantly harder to implement, or rather are significantly harder to implement. So some of the ways in which you would do this in a web application would be by using a polling mechanism, using a timer, or using long poll. So if any of you have used the WCF duplex communication mechanism, that uses a long poll in the background. A long poll is essentially something like your client makes a request, and the request never times out, and so the connection remains open, and whenever the web server has some data to send, it responds to that request, and the client just turns around and makes another long-standing request. So that way, the client always has an open connection, or the server always has an open connection to the client. So that's how long poll used to be implemented. So these were some of the traditional ways. In the new HTML5 standard, some of the there came along some new mechanisms to do the same kind of thing. There's something called server-side events, which are supported by all browsers other than IE, almost all browsers other than IE. And HTML5 also brought a standard called WebSockets. WebSockets are essentially a mechanism to implement, to get socket kind of connections over the web. So you use HTTP to do the handshake, and eventually set up a TCP-based connection over, between the client and the server. And this would give you, a similar similar mechanism of transferring data as a regular socket would have given you in a in a LAN environment, so to say. Having looked at all of these different traditional and new mechanisms, the big problem with all of these is that they need a lot of infrastructure support in terms of being supported by both the client and the server. So, for example, server-side events are not supported in IE. Forever frames are supported only in IE and by nobody else. WebSockets are supported only by the new browsers and the new servers. But even if you had a client and a server both supporting WebSockets, all the intermediate proxy layers should also support it. So, in the bottom line is that if you wanted to use these technologies, you would have to figure out the lowest common denominator which would be supported in your scenario, and then code to that. Or you would need, as a developer, you will need to write if-else kind of logic where you determine the current state of the client and the server and all the proxies, and then determine which mechanism I can use, and then write code against that, and then write, have your logic run against that mechanism, which obviously is hard to do. That is where the need for, or the inspiration for SignalR comes in. So what is SignalR? SignalR